Hello and welcome back to Math 1500 Applied Business Mathematics with Connecticut State Community College. In this video today we're going to look at systems of equations, and we're going to call it systems of equations in two unknown variables. For the purposes of this video and for this course we're going to stick with linear equations. In subsequent courses you may look at systems of equations with more variables. They might be quadratic or cubic, but for this course we're going to look at systems of equations that are linear equations. Now what we mean by a system of linear equations in two variables is that basically we have two linear equations. Okay? We're going to look for the solution to the system of equations if it exists. At the very end of the video we'll talk about those occasions where it doesn't exist. But the solution, if there is one, is the point of the intersection. It's the point where the two lines will intersect when we graph the two lines. Okay, so the solution is an ordered pair. In the majority of the examples I'm going to use in this video, the variables, as you can see down below, are going to be x and y. So we want an ordered pair, x, y, that will indicate the solution to the system. If you're in my course, you're taking a test for me, I'm okay if you give me the solution as the ordered pair x, y, or x equals a value and y equals a value. Okay, I'm actually okay either way, especially depending on the application of the systems. When we solve systems of equations in two variables, there are three main methods that we're going to explore. There's the graphing method, the substitution method, and the elimination method. You'll notice that the elimination method is sometimes called the linear combination method, and you'll see an explanation for each of those terms in a little bit. I will be honest with you that the graphical method, in my opinion, is the least desirable of the three. Yet I'm going to show those to you anyway because I want to make a very strong point about why I want you to see what we mean by solving by graphing or using the graphical method. So if I look at number one, I have y equals 3x minus 2. So I'm going to graph the first equation, y equals 3x minus 2. We know that we have a y-intercept at negative 2. And a slope of 3. So we'll go up 3 and over 1 and up 3 and over 1. And I'm going to sketch my line that goes to those points. Now I really should be labeling, but I'm going to wait and do that after. The second equation, I'll make it green, is y equals negative 5 halves x plus 9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 is about up here. And then we have a slope of negative 5 halves. So down 1, 2, 3, 4, 5, and over 2. And conveniently, we see that these two lines intersect at the point 2, 4. So our point of intersection is 2, 4. The solution to the system is the point 2, 4. Okay? I like to use the graphing method to illustrate to you that the solution to the system is the point where the two lines will intersect. So again, number two, y equals 2x minus 3. So I have a y-intercept at negative 3 and a slope of 2. So I'm going to go up 2 and over 1, up 2 and over 1. I like to count that over a few times. And here's the line represented by y equals 2x minus 3. Again, I'll use green for the second equation. We have a y-intercept of 6, so 1, 2, 3, 4, 5, 6, a slope of negative 2 thirds, and negative 2 thirds. And we see, here's the line that is represented by the green line. Right away, we see that there's an issue here. The point of intersection that we're looking for is not apparently exactly on the point 3, 4, 4, 3, 4, 5, like number 1 was the point 2, 4. So this is a case where solving by graphing kind of breaks down. Two things I want to show you is using the graphing calculator to solve the system. Okay, so you'll notice that the first problem here, number 3, is the same one I had in number 2. I have those two equations. Now I can use the graphing calculator. If you're taking this course for me at Connecticut State Community College, you're taking Math 1500, you've probably been told that the graphing calculator is a requirement, and it is for many aspects of this course. Okay, So to graph using the graphing calculator, I'm going to go to y equals. When I press the y equals button, you'll notice that we have y1, y2, y3. So I can put in, it's actually up to 10 different equations that I can put in. The first equation, okay, the first equation is y equals 2x minus 3. So I simply type 2x minus 3. You'll notice that the y equals is already there, okay? And then the second equation, this time I'm going to just mark it in red since that's what it's going to do in my graphing calculator, is negative 2/3 x plus 6. Now I maybe could put that negative 2/3 in parentheses just to comfort myself, but the calculator is going to do the divide by 3 first and then times the x. Let's go ahead and insert parentheses, and I'll show you in case you don't know how to insert. So I want to put an open parenthesis there. So if I hit second insert, it's the opposite function of the delete, open parenthesis, and then right where the x is in there is where I'm going to want to insert a closed parenthesis. Now if I go to graph, you'll notice it's really kind of hard to see my graph here. If I go to my window, you'll notice that I'm going from negative 0.9 to 14.1 on the x-axis and from 2.7 to 33.7 on the y-axis. It's left over from something I had done earlier with the calculator, but it's a good illustration. I want to reset my window to a standard window. If you notice the zoom button, you press zoom, there are a few preset zooms. And I like to use number 6, which is a standard window. When I press enter, first of all, you can see the blue line, the red line, you can see where they're intersecting. If I press my window button again, you'll notice that my x min and max are now negative 10 to 10, and my y min and max are now negative 10 to 10. That's the standard window. If I press graph again, I can see those two lines. To calculate that point of intersection, I can press second calculate, and what I want is number 5, the intersection. The calculator is going to ask me a few questions, and many people miss at the top here. It says y1 in blue. It says y1 equals 2x minus 3. Is that your first curve? Yes, it is. And all I need to do is press enter to say yes. And then you'll notice up here it says y2 equals negative 2/3 x plus 6. And the question is that your second curve? Press enter to say yes, it is. And then your guess. The quality of your guess does not matter. Simply press enter. And you'll notice that that point of intersection is 3.375. 3.75. I don't think there was any way that I was going to guess that from looking at my graph. So that's a place where graphing method by hand is good, like in example number 1, to reinforce the fact that the point of intersection, or the solution to the system, is the point where the two lines intersect. But what you notice here in number 2 is if the point of intersection is not whole numbers, it becomes very difficult to find those. I can use the graphing calculator. I'm going to switch back to blue here. If you notice number 4, however, 2x plus 3y equals 4, negative 5x plus 3y equals 6. If I go to y equals in my graphing calculator, I have to solve those equations for y. Further in the video, in a few minutes, I'm going to show you why I wouldn't bother to solve this system by graphing. I would use a different method. If, however, you want to use graphing method to solve this, something I would show you is to use Desmos. Desmos is a free graphing application that you can find at desmos.com. Okay, desmos.com/calculator. I'm already here. I am going to do a little bit back and forth. The first equation, notice, is 2x plus 3y equals 4. Actually, let's do the previous problem first. Y equals 2x minus 3. So I can type in y equals 2x minus 3, and I'm just doing that with my keyboard. And you'll notice that Desmos graphs the line. If I want to change color or turn it on and off, I can go here. There's a way to change the color, which I don't think is that important. Then I just cursor down. Just press my down arrow, and the second equation was y equals negative 2/3 x plus 6. So y equals negative 2/3 x. Whoops, see, now notice how this fills that out. I don't want that x in the denominator, so I'm going to backspace, press my right cursor arrow to move the cursor out from underneath the denominator there. So we had negative 2/3 x plus 6. And here's that line. And notice that it just live graphs the lines as we're going. If you notice, there's a little gray point right there. And if I just put my cursor, hover above it, I'm not clicking anything, just hovering above that, you'll notice the point of intersection, 3.375, 3.75. Now, what I like about Desmos is that, I'll erase both of these, I guess. So if I go back to look at number 4, the first equation is 2x plus 3y equals 4. In Desmos, I can just type 2x plus 3y equals 4, and Desmos will graph that equation in standard form quite nicely. Notice again that the graphing calculator has to be solved for y. Okay. Our second equation is negative 5x plus 3y equals 6. I'm sorry for all the back and forth here. But so now all I did was enter that equation just as it was on my page. And you'll notice that here we have a point of intersection. I'm going to hover my cursor right above it. And you see the really fun point, negative 0.285, 1.52324. Okay? So in this equation, this system, there's no doubt I would rather, if I'm going to solve my graphing, use Desmos. In number 3, which is the same as number 2, either Desmos or the graphing calculator will work fine. Okay. Let's look at some other options for solving systems. Okay, we'll do a few different options here. In number 5, notice we have the system x equals 2y minus 12, and the second equation is 4x minus y equals 13. Because x equals 2y minus 12, I can just substitute that in place of the x. So instead of having 4x minus y equals 13, we can replace that x with 2y minus 12. Notice now I only have one variable in this equation, and it would be the y. So 4 times 2y is 8y. 4 times negative 12 is a negative 48. Then we just have minus y equals 13. So I've got an 8y and a negative y is going to be 7y when I combine those. I'm also going to add 48 to both sides. 13 and 48 . 13 plus 48, whoops, no, I don't want to do it here. 13 plus 48 is 61. And now I want to divide both sides by 7. So 61 divided by 7 is 8.7. So y is equal to 8.7. To find x then, I'm going to take that value for y, 8.7, and I'm going to substitute that back in here for x. I'll keep doing this in green. So we had x equals 2y minus 12. So I'm going to put the 8.7 in place of the y. Now, what I'm going to do here is, notice the calculator, I still have that 8.7. I'm just going to do 2 times that 8.7, and I'm using the full value, not the rounded value. Minus 12 equals 5.43 or 5, let's just go with 5.4. So our solution then is the point 5.4, 8.7, okay? And that then would be the solution to the system. Okay, now let's look at number 8. Number 8, what we're going to need to do is solve for x in the first equation. So x minus 3y equals 17. So I'm going to add 3y to both sides. So x is 3y plus 17. So what I want to do now is I want to take that 3y plus 17 and I want to substitute it for x in the second equation. So that second equation will become 3 times 3y plus 17 plus the 4y equals negative 14. Distribute the 3, we have 9y. Distribute the 3 to the 17 is 51 plus 4y equals a negative 14. When we combine the 9y and the 4y, excuse me, we'll have 13y. And now we're going to subtract 51 from both sides, and that's going to equal a negative 65. Dividing both sides by 13, y will equal negative 65 divided by 13, which should give us a negative 5. Now that I have y equals negative 5, I'm going to take that value and plug it back into this equation here. And so x is 3 times the negative 5 plus 17. So that'd be a negative 15 plus 17 equals 2. So x equals 2, y equals negative 5, 2, negative 5. Notice that is the solution to my system. Okay? So now let's look at the third method that I want to show you here, the elimination method. The elimination method is sometimes called the linear combination method. And you'll see in a minute why. You'll notice that numbers 9 and 10 are the same problems as we had in 7 and 8. I just want to give you an alternate method of solution for those. Okay? Because the key here is not that you can only just, the option here is not only that if I say solve a system by graphing, you can do that, or solve a system by elimination, you could do that, but that you'll be able to evaluate a system and determine for yourself which method is the most efficient or the best option for that system. So at number 9, what I want to notice here is that we have 2y and we have negative y. In an inspection, we could notice that if we multiply the bottom equation by 2, we'll do nothing to the top equation. It will stay 5x plus 2y equals 12. But when I multiply the entire bottom equation by 2, well, 2 times the 4x is 8x, 2 times the negative y is a negative 2y, and 2 times 7 is 14. Let me fix this again just a little bit. Then now I'm going to add these two equations together. This is one of the reasons why this is called linear combination method, is I can simply add the two equations together. 5x and 8x is 13x. 2y and a negative 2y is 0. Those are eliminated, which is why some people will call this the elimination method. And that will equal 26. When I divide both sides by the 13, x equals 2. Now, a difference between the elimination method and the substitution method is that in the substitution method, because we had solved the second equation for y, when I got x, I could just plug it right back into there. Now I have to take that 2 and plug it into either the first or the second equation. I'm going to choose the first. No particular reason. So 5 times 2 is 10, plus 2y equals 12. Subtract the 10 from both sides, and 2y is 2, so y would equal 1. So we have the solution, the system, which is the point 2, 1, which, notice, should be the same as what we had up above. In number 10, okay, same problem, same examples that we had in number 8. But what you'll notice is we're going to multiply this top equation by 3. So 3 times x is 3x. 3 times negative y is a negative 9y. And 3 times 17 is 51. The bottom equation is 3x plus 4y equals negative 14. If I just combine my two equations at this point, you'll notice that we have a 3x and a 3x. If we combine 3x and 3x, we'll get 6x. So what I needed to do, what I want to make sure that I do is get the situation so not only do we have the same coefficient, but one of them is positive and one of them is negative. So I'm going to say I should have multiplied by a negative 3. So a negative 3 times x would have given me a negative 3x. Negative 3 times 3y is a positive 9y. And negative 3 times 17 is a negative 51. Now combining these, negative 3x and 3x will cancel each other out. They'll add up to 0. 9y and 4y is 13y. Negative 51 and negative 14 is a negative 65. So once again, when we divide by the 13, y equals negative 5. And we know from what we've done already, when we take that negative 5, it's not x equals, it'd be x minus. I'm using the top equation, x minus 3y equals 17. So x plus 15 equals 17, so x equals 2. We get the same solution to negative 5. Okay, so let's look at a couple more examples. Number 11 and number 12, both of them you'll notice that there is not a situation where I can multiply by x, I multiply x by a value and the x terms will cancel out, or for the y values. So in number 11, I notice I have a positive 2y and a negative 3y. What I'm going to choose to do is I'm going to multiply the top equation by 3. So that top equation will become 9x, right? 3 times 3x, 3 times 2y is 6y, and 3 times 29 is 87. I'm then going to choose to multiply the bottom equation by 2. I multiply the top equation by 3 because the bottom equation had a coefficient of 3. I'm multiplying the bottom equation by 2 because the top equation had a coefficient of 2. So 2 times the 5x is 10x, 2 times the negative 3y is a negative 6y, and 2 times 4 is 8. And what you'll notice here is that now we've got a 6y and a negative 6y, and they will cancel out. So 9x and 10x, 19x, 87 and 8 is 95. When I divide both sides by 19, x will equal 5. And again, it doesn't matter which equation I plug that 5 back into. For x, I'm going to do the top one. So 3 times 5 plus 2y equals 29. So this is 15. So 2y is equal to 14. Y would be equal to 7. So my solution is the point 57. In number 12, I might be tempted to multiply the top equation by 3 and the bottom equation by 2 because those numbers are smaller. However, you'll notice that the top equation has a negative 5y and the bottom equation a positive 4y. So again, I'm going to multiply the top by 4 and the bottom by 5. 4 times 2x is 8x. 4 times a negative 5y is a negative 20y. 4 times negative 14. Let's just do that over here. 4 times 14. 4 times 14 is 56, but it should have been a negative 14, so that's a negative 56. 5 times 3x is 15x. 5 times 4y is 20y, and 5 times 21 is 105. Notice I have a positive 20y and a negative 20y. I can simply add things together. 8x and 15x is 23x. The y's will cancel. And then 105 and a negative 56 is 49. Okay. So then I divide both sides by 23. And x is 49 over 23. I could use that fraction to go solve for y. But what I'm going to choose to do is say, well, I could have, like I mentioned before, is when I had to start the 2x minus 5y equals a negative 14 and 3x plus 4y equals 21, I could have chosen to multiply the top equation by 3 and the bottom equation by 2, one of them being positive and the other one being negative. Let's make the top one negative. So this would give me a negative 6x plus 15y, and that's going to be plus or equals 42. 2 times 3x is 6x, 2 times 4y is 8y, and 2 times 21 is 42 again. Now I'm going to add these two together. The negative 6x and the 6x will cancel. 18y and 8y is 23y. 42 and 42 is 84. Divide each of those by 23. Y equals 84 23rds. Now I certainly could have taken that 49 23rds and plug it back in for x, got a decimal value, tried to make it a fraction, or I could just resolve the equation and get this crazy number for x and this fraction for y. Let's make that 84 look more like an 8. So that should be an 84. Okay? Here's some applications, okay, that we can look at. Resource allocation. Acme Baby Foods mixes 2 strengths of apple juice. 1 quart of beginner's juice is made from 30 fluid ounces of water and 2 fluid ounces of apple juice. 1 quart of advanced juice is made from 20 fluid ounces of water and 12 fluid ounces of concentrate. Every day, Acme has available 30,000 fluid ounces of water and 3,600 fluid ounces of concentrate. If the company wants to use all the water and concentrate, how many quarts of each type of juice should it mix? Now, instead of X's and Y's, I'm going to use B for beginner and A for advanced. Now, you'll notice that we have a total for the number of fluid ounces and a total for of both water and of concentrate. So I'm going to have one equation that's for water and another equation that's for concentrate. For the water, okay, let's back up. 1 quart of beginner's juice is made from 30 ounces of water. So 30 ounces of water will go into the beginner's juice and 2 fluid ounces of apple concentrate. So 2 ounces of the concentrate will go into the beginner juice. Also, 1 quart of advanced juice is made from 20 ounces of water. So 20 ounces of the water goes into the advanced and 12 ounces it goes into the advanced group, and then 12 ounces of concentrate. So 12 ounces of the concentrate go into the advanced. Every day they have 30,000 ounces of water available, and every day they have 3,600 ounces of concentrate available. And there's my system. And now I can solve my system any way that I choose. I think what I would choose to do here is maybe just multiply the bottom equation by 6. I'm going to multiply the bottom equation by 15 so that becomes 30b. So we have 30b plus 20a equals 30,000. Distribute the 15, so 30b plus 15 times 12a, so 15 times 12 is 180a, and that's going to equal 15 times 3,600 is 54,000. Now, one thing you'll notice is I just multiply by 15, so I've got 30b and 30b. One of them's got to be negative. What I'm going to choose to do now is just multiply the top equation by a negative since those numbers are smaller. So 180a minus 20a is 160a. I'm going to fix that 160. That's 160a equals 54,000 minus 30,000 is 24,000. So 24,000 divided by 160. A is 150. How many quarts of each type of juice should it make? Advanced should make 150 quarts. To find B, I'm going to take that 150, and I'm going to put that 150, let's put it in here for A, 2B plus 12 times 150 is equal to 3,600. 12 times 150 is 1,800, so 2B plus 1,800 equals 3,600. Subtract 1,800 from both sides. 2B is 1,800 divided by 2, and so B would be 900 quarts. So that's how much you're going to make of each one of those. Okay. Equilibrium. Equilibrium price is kind of like a break-even point. The demand and supply functions for a particular college newspaper are given by Q equals negative 10,000 P plus 2,000, and Q equals 4,000 P plus 600. Okay, so the first one says the demand and supply function. So the demand function is the top and the supply function is the bottom. At what price should the newspapers be sold so there's neither a surplus nor a shortage of papers? And that's what an equilibrium is. Kind of like a break even. How do I balance things so my supply and demand are equal to each other? Well, if demand, the top equation, and supply, the bottom equation, are equal to each other, well, that tells me that the 4,000 P plus 600 is equal to the negative 10,000 P plus 2,000. Okay, so what I'm going to do is I'm going to add the 10,000 P, so I have 14,000 P. I'm going to subtract the 600, and that's going to be 2,000 minus 600 should be 1,400, right? So that'd be 1,400. Divide both sides by 14,000. P will equal 0.10, $0.1 or 10 cents. The newspaper should be sold for 10 cents in order to reach equilibrium. Okay. So another example of equilibrium price. The demand function for West Podunk is given by Q equals negative P over 10 plus 100, where Q is the number of refrigerators that the citizens will buy each year if the refrigerators are priced at P dollars each. The supply is Q equals P over 20 plus 25, where Q is now the number of refrigerators that the manufacturer would be willing to ship into town each year if the refrigerators are priced at P dollars each. Find that equilibrium. To find that equilibrium, the P over 20 plus 25 needs to equal negative P over 10 plus 100. I can hear you. You don't want to work with fractions. If you don't want to work with fractions, that's fairly easy. The larger denominator is 20. Simply multiply both sides by 20. 20 times P over 20 is just P. 20 times 25 is 500, right? 20 times 25 is 500. 20 times negative P over 10 is a negative 2P. 20 times 100 is 200. No, it's not. It's 2,000. So, adding 2p to both sides, subtracting 500 from both sides, p is equal to 500. So $500 is what the price should be in order to reach equilibrium. Okay. A couple more quick examples of some bizarre things that happen from time to time. In number 16, I'm going to multiply the top equation by -2. So I have a negative 8x from the top equation. I'll have 8x in the bottom equation. So I know that the x's will cancel. However, -2 times -5y is a positive 10y. -2 times 20 is a -40. The bottom equation, we have the 8x minus 10y equals 30. Now when we add the equations together, notice -8x and 8x is 0. 10y and a -10y is also 0. So 0 plus 0 is 0 on the left-hand side of the equation. But -40 and 30 is -10. At this point, I see students do all kinds of bizarre things. Stop and think. You're looking for a solution. When is it that 0 will equal -10? We know that 0 never equals -10, which means there's no x and y value that will make those two equations equal to each other. There's no solution. So we say there's no solution to the system. However, what is it that the solution to a system represents? The solution to the system represents the point of intersection. If there's no solution, that's because the lines are parallel to each other. Okay? And I'm going to go back to Desmos, I think, if I can remember these equations. Right? We got the first equation. All I need to do is just type over this, right? And we said it was 4x minus 5y equals 20. So there's the first equation in blue. Let's get rid of this green one. The second equation is 8x minus 10y equals 30. Okay. Oops, I forgot the y. 8x minus 10y equals 30. Notice the green and the blue line. Okay. They are parallel to each other. There's no point of intersection. Okay. Number 17, I'm going to take this y value and plug it in for y. So 6x plus 2y equals 10. 6x, 2 times negative 3x is a negative 6x plus 10 equals 10. 6x and 6x cancel each other out, and I'm left with a statement that's true. In number 16, the statement was false, so we said there's no solution because the lines are parallel. Here, the statement is true. When does 10 equal 10? 10 always equals 10. Okay? So there's infinite solutions. The reason that there's infinite solutions is because those two equations give us the same line. That says same lines. So 6x, let's go back to Desmos. And let's go back to the top equation. Well, I guess it doesn't matter. 6x plus 2y equals 10. And the second equation is y equals negative 3x plus 5. Notice the green line and the blue line are the same line. That's why there are infinite solutions. Okay? So there's a look at solving systems of equations. We're going to be working with these quite a bit in future weeks, future videos. Again, thank you for watching, and I'll see you next time.